Hi everybody, this is Dave Doyle with BHI Energy, and I wanted to talk to you all a little bit about some knowledge worth sharing in regards to some Anchor Darling double disc gate valves. I know with Dominion right now we're going to be doing a few valves. This fall we're going to have a few clients we're going to be doing these valves. Just wanted to share some knowledge that I had, that I've gathered over the years, and let you know what I think is important for you to remember about this job. Well, as a little bit of background, FlowServe has had a Part 21, which is pretty much an industry notification that there's a problem. In this case, on some of their larger valves, usually 2 inches and over, the stem is threaded into the upper wedge, and there's a pin installed through the hub to fasten the upper wedge to the stem so it doesn't move. In some cases, the stem threaded and torqued in the upper wedge was not sufficient or not torqued at all, resulting in pin failure and an upper wedge separation from the stem. The pin is not being strong enough for many of the motor operated valve configurations, could fail if the torque applied by the motor operator exceeds the shear strength of that pin. So just know that you got to have it torqued and it's got to be pinned to manufacturer's requirements. Valves that aren't affected that are this configuration are the ones that have a linear stem movement with no torque component, such as a pneumatic or a hydraulic operated valve, where it just drives it up and down and there's no twist, no torque applied to the stem. So how does these valves work? Well, as the disc pack is connected to the stem, it kind of just hangs there in the valve body, and with no flow or differential pressure, it's relaxed and it's fully at its minimum dimension. So the stem literally lowers the disc pack in between the two discs until the lower wedge contacts the bottom of the valve. Okay, once the lower wedge contacts the bottom of the valve, the wedge action starts. So the upper wedge slides against the lower wedge, and as the two wedges slide against each other, they expand the disc pack against the valve seats. So in this drawing, there's a blue line showing the stem pushing down, and the two wedges sliding against each other shows the red lines pushing against the discs to the seats. Another piece of OE on these valves is there's a retainer on some of the large valves. And with this retainer, if they're not sized properly, or you've machined the seats over the years, the retainer could actually interfere with the disc contacting the seat all the way. And there has been times where there's been leakage at the 12 o'clock position because the valve disc is actually being hung up by the retainer and it's not contacting the seat fully. Alright, so as many of you have heard when you've worked with me in the past, fundamentals of valves, 80 to 90% of our job is keeping process in the pipe, so it's gaskets and packing, and that's no different on these Anchor Darling double disc valves. You got to keep the process in the pipe. If the valve leaks by, our clients can generally deal with a little bit of leak by, but they cannot deal with it leaking out of the pipe. So remember, keep the process in the pipe, and your fundamentals on gasket compression and your packing consolidation is wicked important. Alright, a fundamental that's valve specific to this valve that I'll start with is match marks and flow direction. The orientation of the upper and lower wedges with regards to the flow direction is critical for this application. Understanding the upstream orientation of the valve is vital to the setup of the valve. In many procedures, and particularly in some of the Dominion procedures, there's engineering verification of which physically identify in the field what is the upstream side, because the upper wedge needs to be on the upstream side. So it's vitally important as the valve comes apart that everything is match marked, so no matter who comes behind you, they can put it back together the way it should be put. So it's critically important to match mark, understand the flow dimension, and last but not least, sometimes these valves have holes drilled in one of the discs. This was to prevent overpressurizing the two discs and to prevent a phenomenon called pressure locking. and it's very important that the disc with the hole drilled in it ends up where it needs to be. Okay, another fundamental. In these valves, there's no wedging action, per se with the stem and a wedge-shaped wedge. These are parallel seats, and it's very important that they are parallel and they're flat. Okay, if they're not flat, you're going to have a leak. If they're not parallel, you may have a leak. There is a bit of forgiveness in the disc pack, but not much. They need to be parallel. And as seen in this slide, and this is a procedural requirement from various customers, but it's almost a 1/4 of an inch the seat width. In this case, this is saying it could be a 1/4 inch and less, but the seats are very narrow, and in this case, if you put a machine in there and you start lapping, you can take a lot of material off quick, so you need to be very, very careful. Another fundamental about this is the disc pack dimensions, understanding the minimum dimension and the maximum dimension. In this picture, it's E. It's critical that the E dimension is understood in the disc pack. The minimum dimension is with a fully relaxed assembled disc pack. The minimum dimension of the disc pack is such that the disc pack will fit in between the seats when installed in the valve. Simple as that. It's got to fit in the valve between the seats. The maximum dimension is when the lower wedge is pushed into the upper wedge and the disc pack is fully expanded. When the disc pack is fully expanded, this is your maximum dimension that it could be between the seats. The sweet spot on these valves is like 25 to 75% of the disc pack dimension. If you think of 0% being unexpanded to 100% being fully expanded, the seat widths face to face in the seat needs to fall between the 25 and 75% dimension of the E dimension. And I know I'm talking about this quick. Talk about it with your wingmen, talk about it with your supervisor, talk about it with the engineer. This is very, very important to this design. One of the last fundamentals I want to talk about is the disc guides. Okay, there has been times when if you replace parts and parts might be just marginally different sizes than it was previously. In this design, there's guides that run the length of the body that guide the discs to center the discs into the seats as it goes down. And in actuality, the discs can actually roll up and down these guides. As evidenced by this picture you see here, in the lower left-hand point, you see some shiny bits on the discs, and you can see that's where there was contact with the guides in that particular application. And on the right-hand picture, you can see a bit of a rub mark. And so last but not least, my summary. My little tagline here is safe quality craftsmanship is fundamental. So what are the fundamentals of this job? Process in the pipe, gaskets and packing. Again, it cannot leak out. It can marginally leak by, and our clients can live with it. But due to our diligent efforts of making great seat contacts, we can minimize that risk. But assuredly, a client cannot live with a valve leaking out of the pipe. Orientation and match marks. Make sure they're very clear, and anyone coming behind you can read your documentation and totally understand how that valve goes back together. Seats are parallel and flat. In this application, they have to be parallel and they have to be flat. Again, flat means no leaks. Parallel, there's a little forgiveness in the disc pack. It doesn't have to be absolutely exact, but they have to be flat. Disc pack dimensions. You need to understand the minimum dimension and the maximum dimension as it relates to the face-to-face dimension of the seats. And last but not least, guide and disc clearance. Make sure the discs fit in the valve, dry fit the wedge pack if you can before it's torqued to the stem. Wherever you can, try to do some dry fitting. Anyway, I appreciate everyone listening to me today. Be safe out there. Look out for your wingman. gaskets and packing. It's all about fundamentals, you know, and please, when you're dealing with high energy, look out for the line of fire, know where the energy goes, and look out for your wingman. Thank you very much.